Hi everyone, we are from the TikTok user growth data science team. Our team focuses on attribution, causal measurement, and LTV modeling for large-scale advertising systems. Today, we are going to present our paper, Attributed but Not Incremental Cannibalization-Corrected Attribution for Large-Scale Advertising. First, we're going to talk about the problem, why attributed conversions can overstate true growth. Second, we will introduce our method, our framework to correct the attribution. And finally, the validation and the real-world impact from deployment. Let's start with the core problem. Attribution is not always the same as incrementality. A user may be attributed to paid ads, but that doesn't always mean the user comes because of the ads. Some users would come through organic traffic even without the ads. That part is cannibalization. And if we act on the wrong attribution signal, we make the wrong decisions. This is not just a measurement issue, it becomes a budget issue, and at scale, that gets very expensive. So why not just fix the bias? The truth is we have attribution and experiment, but neither signal is enough on its own. Attribution is available every day, but it's biased. Experiment tells us the real lift, but they are expensive and sparse. We can't run them everywhere every day. So our idea is simple. Use the sparse experiments to calibrate the daily attribution signal. Here's exactly what our framework does. We treat incrementality experiment as causal anchors. The AdKDD transfers the causal signal from those experiments into daily correction estimates. The HCA parts pushes that correction down to finer business units. Together, they give us a decision-grade signal. Experiments are noisy, so before we trust them, we build clean anchors. First, we align the experiment scope with the attribution scope. Then we filter that, we will filter out underpowered or noisy signals, things affected by insufficient delivery, abnormal blocking, or some configuration changes. What's left is a set of qualified causal anchors we can use. The AdKDD then transferred that causal scale into daily correction. We learn a mapping from production features to the anchor lift. This is not a model complexity paper. In production stability and interpretability, it matters more. So we use a robust Uber style objective that done with noisy readouts and boundary control that keeps correction in a plausible range. A channel level correction isn't enough. Teams act at finer units like campaigns. So HCA allocates the calibrate down to channels, subchannels, unto individual user. It preserves consistency, so fine-grained corrections is due sum to the calibrated totals. That's what makes the correction actually usable in operations. For the validation, we use a forward in time setup. We train on earlier experiment runs and test on the new runs in the model hasn't seen yet. Then absorb that run into training. So each test is truly out of sample, and this gives a realistic view of performance over time. Here's the main result. Compared with raw attribution, our method reduces normalized error by over 91%. This is not a small improvement. It's a big correction to structurally biased signal. And this improvement holds across different slices, not just at the aggregate level. Across different business class, we still see a much higher error distribution. That matters because the signal is used by many downstream teams in many different settings. Okay, so now impact, we deploy this as a correction layer on top of the existing pipeline. After rollout, we saw about 50 percentage point drop in cannibalization rate across markets. The correction signal changed how we read paid contribution and help teams turn budget and traffic strategy using better numbers. Better measurement makes the better decisions. Then let me end with limitations. The method still depends on experiment quality, so we need to keep monitoring that. And detailed outputs are not fully causal, they are allocations. And the third, negative cannibalization is still hard to model well. For next steps, we want to look at cross-channel effects more deeply, make recalibration more automatic, and handle different markets better. Okay, so that's all. We are happy to take your questions. Thank you very much.